Welcome to this video lecture on the subject electromagnetic fields. So in this lecture we are going to discuss about current and point form of Ohm's law and continuity equation. So what is meant by current and current density? So there is electric charge in motion constitutes an electric current. So we are going to discuss about current flow in the different materials. So in metallic conductors the charge is carried by electrons. So in liquid conductors like electrolytes the charge is carried by ions, both positive and negative. So in semiconductors the charge is carried by electrons and holes, the holes behaving like positive charges. The flow of charge per unit time or rate of flow of charge at a specified point, so is called as in electric current. So which is governed by the equation of I equal to d by dt of q, coulombs per second, or it is amperes. So due to the movement of free charges, several types of electric current can be caused. So first one is conduction current, another is convection current. So conduction current is due to the drift of electrons and holes and occurs in the conductor and semiconductors. So motion of ions gives rise to electrolyte currents, and convection current results from the motion of electrons or ions in an insulating medium such as liquid, gas and vacuum. So while in dielectrics, there can be flow of charges under the influence of electric field intensity. So such current is called as the displacement current or convection current. For example, current flowing across a capacitor through the dielectric separating its place is an example of convection current. The analysis of such currents in the field theory is based on current density at a point in the field. So current density is a vector quantity, so it is denoted as J vector. So this current density is used to derive the Maxwell's equations, which is stating the propagation of electromagnetic fields. So current density can be defined as the current passing through the unit surface area when the surface is held normal to the direction of the current. So this is measured in amperes per square meters. And we can see the relation between current and current density. So when J vector and ds vector are right angles, then we can write dI can be written as J into ds, where J is the current density in ampere per meter square. So if J is not normal to the differential area, then the total current is obtained by integrating the incremental current. So we can write I equal to integral over the surface J vector dot ds vector. So it is a dot product. So then the current density is obtained in amperes when it may be noted that J need not to be uniform over S and S need not to be a plane surface. So next we can see the continuity equation. So continuity equation of the current is based on the principle of conservation of charges. So the principle states that the charges can neither be created nor be destroyed. So we can derive using the previous relation of current and current density. So the total current I crossing the surface is given by I closed surface integral J vector dot ds vector. So this current flows outside from the closed surface. So it can be mentioned earlier, the current means the flow of positive charges. Hence the current I is constituted due to the outward flow of positive charges from the closed surface. So according to the principle of conservation of charge, there must be decrease of equal amount of positive charge inside the closed surface. So hence outward flow rate of flow of positive charge gets balanced by the rate of decrease of charge inside the closed surface. So we can derive continuity equation from Q equal to charge within the closed surface. So we can write d by dt, that is the rate of decrease of charge inside the closed surface. So due to the principle of conservation of charge, we can use the rate of decrease is same as the rate of outward flow of charge. So we can equate the previous two equations, that is integral over S J dot ds equal to minus dq by dt. So this is the integral form of continuity equation. So from this equation, if the current is entering the volume, then we can write integral J dot ds is equal to dq by dt. Here we use plus sign. The point form of continuity equation can be obtained using divergence theorem, where we can convert the surface integral to volume integral. So we can write integral s j dot ds is replaced by integral volume del dot j into dv. Here del dot j means that it is divergence of flux density, divergence of current density. So minus dq by dt equal to integral del dot j dv. So we can substitute volume integral rho v dv for charge, whereby rho v is the volume charge density. So when we substitute volume charge density, we can rewrite to dou rho v by dou t. This is derivative becomes partial derivative for a constant surface. So relating the left hand side and right hand side equation, it is for del dot j into del v for an incremental volume. So it is equivalent to minus dou rho v by dou t into del v. So when del v cancelled, del dot j equal to minus dou rho v by dou t. So this is the point form or differential form of continuity equation of current, where we are relating the divergence of current density to rate of change of current density, that is volume charge density. So this relationship between J vector and E vector will give point form of Ohm's law, where we use the conductivity of the material. So in terms of conductivity of the material, for metallic conductors, J vector can be written as sigma into E. Sigma is the conductivity. So it is measured in moles per meter. So this equation is known as the point form of Ohm's law, so which we are using to study the conducting materials. So we can take the small assessment. So first one, find the conduction current density when conductivity of the material is 500 units and corresponding electric field is 2 units. So from this question, we are going to derive find conduction current density, which is denoted by J. So it is equal to sigma into E. So we are given sigma value, that is 500, and E value is given. So when we substitute this, we get 1000. And second question, calculate the displacement current density when the electric flux density is 20 sine 0.5 t. So electric flux density and displacement current density are related by J equal to dou by dou t of d. So we have to differentiate the flux density. So we get cos 0.5 t into 0.5. So the answer is 10 cos 0.5 into t. So these are the references. Thank you for listening.